Hello, seventh graders. I'm so happy that you are able to watch this video in case you do not make it to your classroom's Google Meet. All right, so today we are moving on to solving proportional relationships. All right, so this ties in with so many different type of architecture and measurement. Cooking is a real life skill that you will need to use in your life at some point. Okay, so we have solved whether a table or a graph is considered proportional. So now we are going to take some other situations and find out if they are considered proportional or find our missing value that should fit for two fractions that are equal to each other. Okay, so we are still in chapter 1 in volume 1. And this is going to go after our insert of graphing proportional relationships. All right, so if you're keeping your notebook nice and organized, that's where it goes. Alrighty, so we have fruit smoothies. Kate and some friends want to buy fruit smoothies. They go to a health food store that advertise a sale of 2 fruit smoothies for $5. Okay, so fill in the boxes to write a ratio that compares the cost to the number of fruit smoothies. So right there tells us how to write our ratio. We are going to put cost on top and then fruit smoothies on the bottom. Well, what does the sale tell us? The sale is telling us that there are $5 for 2 smoothies. That's our ratio. Okay. So suppose Kate and her friends want to buy 6 smoothies altogether. So how much would that be? Well, if we actually had some type of way to figure this out, if we're doing 5 smoothies and we would double it. That's the same as having 4 smoothies, right? Well, 2 times 2 is 4, 5 times 2 is 10. What about then if we had our 6 smoothies? We would then multiply by 3. So 5 times 3 gives us $15 for the 6 smoothies. All right, those are all equivalent ratios. All right, so is the cost proportional to the number of fruit smoothies and 2 and 6 smoothies? We would say, let me tap it. Where'd my typing go? All right, well, I had it typed there. There we go. Yes, all ratios then reduce to 2.5. All right, so if I took my 15 divided by 6, I would get $2.50 per smoothie. The same thing if I took $5 and divided by 2. So, and remember, being proportional means all of the ratios are equal. So remember, a portion is an equation stating that 2 ratios or rates are equivalent, equal, the same. All 3 words go together. Equivalent being your more mathematical 7th grade level term. Okay, so we're going to actually work with doing this. Okay, so to find cross products, we are multiplying diagonally. Okay, so we want to actually take the numerator from one fraction and the denominator from the other and multiply them. And whatever their product is should equal the same as the other product that we go across. So if you look at example 2 here, we know we need to take 8 times 3. Okay, my numerator, my denominator, not from the same fraction, from different diagonal forms. Then we have 6 and 4 that we are multiplying. These are all different numbers, but their products get the same. So these are equivalent. So 6/8 is equal, the same, equivalent to 3/4. But there are going to be times here where we're going to have an unknown value. So there's a variable sitting there that we have to find. Take it and multiply it with the diagonal, so it gives us 5x. And remember, you always put your coefficient first with the variable. It's not x5, it is 5x. Then we have to take our 4 times 7. So we set it up this way, the very first one, so that we know what we're multiplying. Then multiply your two integers. And then look, we have one-step equation right here. This is your one-step equation. We've done that before. This is multiplication. What's the opposite of multiplication? Division. Okay, so when I divide by my 5, those two cancel out. And then I just take my 28 and divide by 5 to get 5 6/10. Now, not every time are you going to get an integer. There are times you're going to get decimals with this. Okay, so you're going to need to make sure you pay attention to your products and division. So let's practice them together. Okay, so let's look at, is x fifths equal to 15 25ths? Well, we need to find out what x equals. They're telling us it is equal and that it's proportional. Okay, so we are going to solve, and then of course we are going to check. Okay, so going diagonally, I'm going to put 25x. Okay, and then even if just to show you a color-coded version of where we're getting our numbers, this is the same as 5 times 15. Okay, that's just there to show you how color-coded. That's setting it up. All right, so then I just need to take my 5 times 15. So we're saying 25x equals 75. Now this is multiplication. What is the opposite of multiplication? Division. And what am I going to divide by? Well, whatever's with the variable. The coefficient is what we always divide by. I'm going to divide both sides by 25. Now we only have x on the left side. And we did this the whole month of December. So you should remember hopefully how to do this. All right, and then 25 goes into 75 3 times. Okay, but then of course remember the checking. All right, so we want to see, is 25 times 3 equal to 75? 75 equals 75. Bada bing, bada boom. Okay, if you need to, pause this, go into doing your next one. All right, so for the next one, 3/4 equals 12c. Well, what does c equal? We're going to go ahead and take my diagonals. It's 3 times c. Then take your diagonal of 4 and 12. 4 times 12. You can use the dot. You can do parentheses. But do not use the x to put multiplication anymore. Remember, now that we're working with variables, it's a little hard to do that. All right, so 3c equals 4 times 12 is 48. And we know the opposite of multiplication is division. It's our inverse operation. Cancel your 3's out. And then take 48 and divide it by 3. 3 goes into 4 one time. And goes into 18 times. And of course, we're going to check it. Check it. All right, is 3 times 16 equal to 48? And I got 48 because I took 4 times 12. All right, so 3 times 6 is 18. 3 times 1 plus 1. We are good. Our equation is correct. Alrighty, two more, and then, oh, actually, two more, and then we get to our own word problem. Alright, I always start with where the variable is, just so that I know my variables can be written on the left side of the equal sign. Does it really matter? No, it's more of a preference. Alright, and then I gotta take my 16 times 15. Ooh, double digits. Alright, so 16 times 15. 5 times 6 is 30. 5, 6, 7, 8. Add my 0, 1, and 6. Add those up, 240. So we're saying 24 times z equals 240. Well, what am I going to divide by? I'm going to get z by itself. I'm going to divide by 24. Those cancel. And I know 24 goes in 240 10 times because it's 24 with a 0 at the end. So then we just need to check it. All right, so I'm going to use this equation that we started with, 24z. Instead of z, what am I supposed to put there? I'm supposed to put my 10 equals 240. All right, well, 24 times 10 is 240. So far, so good. We are correct. Right, so all of that in hindsight is telling me that I know 16/24 is the same as 10/15. If I was to reduce all of these down, they would get the same ratio. All right. So then W, right? So another way, when we go to check this, I'm going to check it using our ratios. Okay? Equals 6 times 2.5. Okay, so 7W equals, well, times 6, I get 40, not 14, 48, 12, 13, 14, 15, 16. All right. What am I going to divide by? We should know, right? We're going to divide by 7. 168. Divide by 7. 7 goes in 16 twice. And goes into 28 4 times. So we are saying W equals 24. All right. So if I replace W with my 24 in my, did I put that? Oh, I forgot to put my decimal. All right, so my decimal goes right here, right there, right there. There we go, 2.4. I knew something was off when I put that in because my top number was larger than my bottom number. So this is our original. If I replace my W in the equation with what I got down here, then take your two numbers and multiply them. 7 times 2.4 and 6 times 2.8. And see if we get the same number. 7 times 4 is 28. 14, 15, 16. We want to see if we get 16.8 both times. And we do. Okay. So I hope you have a great notes, quick going over through that. Yes, I know. But we already know how to do one-step equations. So all we have to do is cross multiply, use your cross products, set them up as one-step equations, and solve them. All right, so here is the exit ticket. Solve each proportion, and yes, you should be checking your work. either whether you're checking the proportions are equal or using it for your checking of one-step equations. Alrighty, have a great day.